Hello everyone. Today I'm going to talk to you about my experience of teaching my Year 7s about equivalent fractions through the use of a fraction wall. But before I get into the details of that, I'd just like to discuss some of the common misconceptions that children often have around fractions. So the first one, which is supported by the research, is that often children assume that if the numbers at the numerator and denominator are bigger, then the fraction is bigger compared to another. So for example, I've had children in my own lesson come up to me and say, "Oh, sir, but isn't 1/8 bigger than 1/4?" Which you obviously know is not the case. Um, so this also kind of leads on to the next one, which is another common misconception is that students do not understand that fractions are numbers. Um, I've noticed that children tend to sort of box sections of maths and put them into these little boxes and say, no, there's no link here whatsoever to any other part of maths. That's something I do come across a lot. There's also issues with children's understanding of fractions operations. Children treat fractions as integers or whole numbers, and they apply the rules of natural numbers to them, which actually links to the first bullet point. So they often use the rules of natural numbers when applying it to fractions, which of course is not the correct way to do it. So interestingly, this seems to be a frequent issue. So another study found that children tend to relate fractions to their knowledge of whole numbers and natural numbers, which again is incorrect. This seems to be cropping up quite a lot within the research. Um, Another study found that conceptualizing fractions as part of whole amount is not adequate enough for developing a complete understanding of fractions, which again is quite interesting because um, during my time teaching my Year 7 class, as part of the scheme of work often states that I need to make sure they understand that fractions are part of a whole and all that sort of thing, and have them, a circle divided into slices and shade it and sort of go down that route. Maybe that's not the best route according to the research. Um, and again, another error stated is that a common error for students when adding fractions was that they added numerators and denominators together, which again, you're not meant to do. This links into this whole issue of children seem to just be applying the rules of natural numbers to fractions, even though they're not meant to. And again, in this bullet point, even though the students were warned not to do it, they still went and did it anyway, which is something I've experienced myself. Next, I'd like to move on to models used in teaching fractions. If you look at the top right-hand corner, you'll see the area or territory model. This is particularly useful when introducing that fractions are part of a whole concept. However, there is evidence that this model has become overused and can actually cause some of the misconceptions I mentioned before, such as students adding across numerators and denominators when adding fractions, for example. Next model is a number line, which you'll see generally focuses on the distance from 0 to 1. It's particularly useful if you need to see how many of a particular fraction you need to add to get to one whole. In this case, you'll see 1/3, so you can see 3 1/3 are needed to get to 1. So the research does indicate that incorporating or using number lines into the teaching of fractions is quite a good way to sort of strengthen their understanding, particularly with sort of the measurement or maybe even size of fractions, because that is something that students do struggle with. The next model we're going to talk about it goes by a few different names. So the length model, bar model, or as I like to call it, fraction wall. You'll see a small example towards the sort of bottom right of the screen. So it's just simply a bunch of tiles and you're dividing them up into fractions. So often you'll have one at the top, that will be your biggest tile, and then you go into halves, thirds, and you can keep going for as many tiles as you need. And they're often color coded into different sections. So again, there's evidence that fraction was particularly helpful in enabling students to tackle problems with equivalent fractions when used in a virtual or sort of pen and paper based format. So in fact, there was a study using both the virtual and traditional format, and that showed that students' accuracy in solving equivalent fractions improved when using both methods. But what was even more interesting is that it showed the majority did better with the virtual version. So here is my resource that I used in my lesson to help teach this topic. On the left, you'll see a picture from one of my students' books in which I got them to stick it in. And the middle and picture on the far right are examples of the electronic version in which you can manipulate it, change colours, stack them, and all the rest of it. So put it simply, the reason why I use this is because I felt it would be appropriate for my class, and it's supported by the research. As you saw on the previous slide, there's not tons of research devoted to specifically teaching equivalent fractions, but what I could find did seem to support the use of a fraction wall. So I decided to trial both a paper and an electronic copy in the lesson. That study I mentioned in the previous slide looked at its use with SEND children, which again is appropriate for my class because it's a class of 28. 12 of them have SEND in my class, with 3 of them having a very high level of SEND. So I just hope that it would help them to visualize sort of the fractions and actually see the magnitude and size of each fraction and how they're bigger compared to the other ones. I also hoped it helped them sort of be a bit more independent. So if they did get stuck, they could turn to the back of their books where it's been glued in and try and tackle problems for themselves. So next I'd like to move on to the structure of my lesson and how it went. So this was my starter activity, which lasted about 10 minutes, differentiated into red, amber, green and extension. Knowing my class as I do, I would expect most of them to attempt either the red or amber section. Very unlikely, but possible we might have someone attempting the green section. We covered it briefly in the previous lesson. This was more just to sort of get them settled and thinking about equivalent fractions again. Because then further down the line, once I've introduced the resource and shown them how to use it, my hope is they would go back to this and improve upon their answers. So after about 10 minutes spent on the starter, instead of marking it like we normally would, I just dove straight in and decided to show them the resource. So this is what it looks like when it's first introduced. You'll see sort of in the top right section, I had the denominator set at 12. You can set it at whatever you like. It can get bigger or smaller depending on what you need. And then I went through some examples. So what I decided to do was, for example, okay, when I was showing trying to find the equivalent fraction for 2/4. So I wanted to find the quartiles and I got them to identify where they were. So they shouted out to me, you know, it's the green tile just below 1/3. Then I decided, I got a ruler. I counted the 2 tiles, so it's 2/4. I wanted 2 of those tiles. Placed my ruler at the edge of the second tile, and I just instructed them to visually have a look for me and see if they can see any other tiles that line up to the edge of the edge of that quartile. And a couple of them were able to show me, oh yes, so a half is the same, and a couple other fractions. And that's sort of how we proceed. I just wanted to get them comfortable with it, introduce it to them, and yeah, before we moved on to any harder questions. So those were the ones we went through together as a class. So after introducing it to them electronically, I got some helpers to hand out a paper copy for me and they glued it into their books. Then we revisited the starter, which you'll see a small picture of it just there, the red, amber, green, a half, 1/3, 2/5 and 7/12. The fraction wall I gave them went up to 12s. So they should have been able to attempt most of it, or I hope at least improve upon their previous answers with the aid of this fraction one. So we spent some time on that, and then once I felt they'd gotten the most out of that, we decided to move on to a sort of fun equivalent fractions colouring in task. So you'll see it on the left there. So it pretty much does what it says on the tin. So for example, if you're trying to find you know, fractions that are equivalent to a half, you'd colour them all in blue. I'm aware that the fraction wall wouldn't help with every single fraction listed on that worksheet. However, I didn't want them to become totally reliant on the fraction wall, that they couldn't do anything without it. It's just to sort of get them started and help them get involved in the process. So yeah, that was the last task for the lesson, and then towards the end of the lesson, I gave them the feedback sheet or pupil survey for the fraction wall to complete. Now I'd like to move on to the feedback I received from my students. As you might recall, I have 28 students. Of those 28, 25 completed feedback forms for me. Four very simple questions. We just circled the answer that they felt was applicable to them. And question 5 was just for a space for them to write any comments or thoughts they had about the fraction wall in general. So of the 25 students that responded, 23 of those 25 preferred having a paper copy compared to just 2 who preferred the sort of whiteboard version at the beginning of the lesson. Now, interestingly, 20 students answered yes to using fraction wall again in another lesson versus 5 who said they would not. So overall, it seems that the students liked having the fraction wall in the lesson. There's also some interesting responses to question 5 that I've put at the bottom of the slide. So a couple points that seem to be cropping up from these responses, and also what I heard in the lesson, was students would like more tiles. Some of them were still finding, well, some of them found that it was a bit blurry, the electronic version. So a couple of students at the back couldn't see it, so which I think is why the majority of them preferred having a paper copy of the fraction wall. One person said it sort of helped them with their times tables, which was interesting. And another student says it helps so you can see if you got the fraction right. Which again, I think comes back to that technique I said towards the beginning of the lesson of lining up the tiles with your ruler and just seeing which ones are similar lengths to answer the question. So here are some pictures of 2 pupils' work that they completed during the lesson. So if you look at the 2 pictures on the left hand side, this student was unable at the time to make progress with the starter. However, they did make progress with the worksheet, which is interesting because one of the questions for the starter was actually to find fractions that are equivalent to a half, but it did seem that they were able to shade in and identify some fractions that are equivalent to a half on the worksheet. And he or she even managed to shade in one fraction that was equivalent to 2/3, which is fantastic. If we look at the work on the right hand side, this student made a bit more progress with the starter. So they were able to find some fractions that were equivalent to a half, which is fantastic. And on the work, they seem to make a bit more progress on the worksheet. So they managed to find quite a few fractions that are equivalent to a half, which is fantastic. And even some that weren't on the fraction wall, which is again is fantastic. I believe they shaded in 200 over 400 again, which is quite a tough one if you think about it. And they managed to shade in a few answers for the question about fractions being equivalent to 2/3, which is great. So I'm convinced that maybe with a bit more time, they would have made even more progress. So next, I'd like to move on to the feedback from my teacher, mentor, and the observer. Let's start with the observer. So lesson was well structured and differentiated. It was at an appropriate level for the students. By the end of the lesson, she did say that most of the students had shown progress, which was fantastic. There was some good discussions with the students. I think particularly when we were discussing how to use the fraction wall, that was a very useful discussion, and that the fraction wall was good for helping the students visualize the fractions. With regards to the teacher mentor, she said clearly overall the fraction wall was a helpful resource and helped them make progress. Perhaps next time we best stick to the paper copy, which I do agree with, as some students at the back struggled to see when I was using the e-whiteboard version. For students who are unable to make progress, perhaps a different type of resource would be useful, such as the number line, which is supported by the research. And I did need to factor in that it was a period 5 lesson, so students would not normally work as well as they would. Next, I'd like to move on to my self-evaluation of how the lesson went. So overall, I felt the majority of students of varying abilities were able to make progress by the end, which is fantastic. My lesson does support the research in the sense that a fraction wall is a good aid in teaching equivalent fractions. However, my lesson disagrees with the researchers' view on the use of an electronic version being superior. My research, my lesson also agrees with the research in that I found that children tend not to think of fractions as numbers again, which was an issue I was sort of noticing and coming across. Um, yeah, so in terms of improvements, I feel that next time 100% I will stick to a paper format resource. I feel like maybe I could have differentiated a little bit further, maybe either spent a bit more time explaining it, or maybe have some instructions or steps written on the resource to help students use it more effectively. And maybe for those who were still struggling, having their own sort of separate differentiated resource like a number line, or maybe combined with the sort of area model parts of the whole. Um, and when students were tackling the worksheet, maybe I think it would have been a better way of doing it would have been to have them in pairs or groups. So it make it a bit more enjoyable, and it maybe help support the weaker students through discussion. And now I'll move on to my reference slides. I do apologise for the size of that link. I was unable to shorten it. Here is my second reference slide. Here is my final reference slide. Those of you who are interested in using the fraction wall, the link for that is on the very last bullet point for a website called MathsBot.